Section 1.7 deals with quadratic equations. So to first define a quadratic equation, we will let A, B, and C be real numbers. So remember that means be an element of the real numbers, with A not equal to 0. And we'll talk about that restriction in just a minute. An equation is quadratic if it can be written in the form ax squared plus bx plus c equals 0. I put a c, not an x. There we go. So what makes an equation quadratic in particular is this x squared term. So if we have a, b, and c are real numbers, these are just our coefficients. But we have to say that a cannot be a 0 coefficient, because if a is 0, then the x squared term is no longer there and it's not quadratic. So that's that reason for that restriction. Another property we're going to use is called the zero factor property. This property says if A and B are elements of the real number system and A times B equals 0, then either A equals 0 or B equals 0, or possibly both. Now, these are not the same, A and B, as the definition of a quadratic. This is a totally separate property. But what we use that for is for solving quadratics. So just to put that to use right here off the bat, example number 1, if you have a factored quadratic that is x minus 5 times 2x minus 3, and that's set equal to 0, then the zero factor property says that either x minus 5 must be 0, or 2x minus 3 must be 0, or possibly both. And then we solve each of those equations simultaneously. So for the one on the left, I would add 5 to both sides and get x equals 5. For the one on the right, I would start by adding 3 to both sides, 2x equals 3, and then divide by 2 is 3 divided by 2. So my solutions to this would be x equals 5 or x equals 3 over 2, according to the zero factor property. So we use that, like I said, when solving quadratics. So this particular quadratic was already factored and set equal to 0. Example number 2, we're going to need to do a little bit of back work. We have x squared minus 8x equals 15. So when you begin solving a quadratic, you have to start by putting it in this standard form that we saw above. So it needs to be set equal to 0, the x squared term, then the x term, and then the constant. So we're really close here, except this 15 is out of place. We would need to add 15. Oh, that's supposed to be a negative 15. We would need to add 15 to both sides. Now with like terms, 15 doesn't have an x or an x squared, so none of those get added together in actuality. They just get added all together on one side, and now it's set equal to 0. And then at this point, we need to factor. Since there's no number in front of x squared, we just need to look at the number on the end, our c value, find factors of 15 that multiply to give us negative 8. Those factors would be x minus 5 and x minus 3. Because negative 5 minus 3 would be negative 8, and negative 5 times negative 3 would be positive 15. So now we have our quadratic factored and set equal to 0. We can use the zero factor property to say one of those factors must be 0, or the other one, or potentially both. So to solve x minus 5 equals 0, adding 5 to both sides would give me x equals 5. Or x minus 3 equals 0. Add 3 to both sides and get x equals 3. So those would be my two potential solutions. Another method we can use is called the square root property. This does not apply to every quadratic, but it's convenient when it does. If we let a and b be real numbers, and our b value is greater than 0, then the solutions of x squared equals b are the square root of b and the negative square root of b. So let me show you example number 3 for how we use this. If I have the quadratic y minus 4 squared equals 11, I could multiply y minus 4 times itself on the left side and do exactly what I did above, or I could square root both sides of this equation, and I would get y minus 4 because the square and the square root would cancel. But on the right-hand side, the square root of this number could either be positive 11 or negative 11. So I put a plus or minus, square root of 11 on that. And then to get y by itself, I would need to add 4 to both sides. So the solution would be written as y equals 4 plus or minus the square root of 11. And that's using the square root property. Okay, another method we use with quadratics is the quadratic formula. So we have to use a quadratic in standard form for this. So we say the solutions of the quadratic equation ax squared plus bx plus c equals 0, where a is not equal to 0, are given by this formula. X is equal to negative b, or the opposite of b, plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So let's use that formula in example number 4. I have x squared plus 1 equals 4x. To use that formula, I need to begin by putting my quadratic equation in the proper form. So this 4x is out of place. I would subtract 4x from both sides. So x squared minus 4x plus 1 equals 0. And then I like to identify what my a, b, and c are. So now I know that a is 1, b is negative 4, and c is 1. And I can plug directly into the quadratic formula. So I have the opposite of b, so negative 4, plus or minus the square root of b squared. I encourage you to always put your b value in parentheses and then square that. So if there's a negative there, that will make sure the negative gets squared as well. So b squared minus 4 times my a value 1 times my c value 1. All of that divided by 2 times a value is 1. So simplifying, negative 4 is positive 4, plus or minus, and then under my square root, negative 4 squared would be positive 16 minus, this would be 4, 16 minus 4 is 12, divided by 2. So that would be a correct answer, just not completely simplified. So I could simplify that radical. The square root of 12 has a perfect square of 4. So I can square root the 4 out of the radical and get 2 times the square root of 3. And then I also noticed that the 4 and the 2 and the 2, all of those could divide by 2. So I could simplify even more to make it 2 plus or minus the square root of 3. So if this were a problem where you needed decimal values for the answers, you would use your calculator and do 2 plus the square root of 3, which is 3.7321, and 2 minus the square root of 3 is 0.2679. So this plus or minus just gets separated to give you the two solutions. Okay, my next definition for you is what we call the discriminant. The discriminant of a quadratic equation is determined by the part under the radical in the quadratic formula. The part in particular we're talking about is b squared minus 4ac. This is the discriminant. So the value of the discriminant tells us a lot about our solutions. If your b squared minus 4ac is positive or greater than 0, that means you have a quadratic that looks something like this. It crosses 2 times on the x-axis, so it has 2 real solutions. Okay. If b squared minus 4ac is exactly equal to 0, that means your quadratic just comes down and touches the x-axis and goes back up. So it only has 1 real solution. And then if your b squared minus 4ac is negative, that means you have this parabola that's just kind of floating out in the air. The solutions are where it touches the x-axis and it doesn't. So this has no real solutions. And you can tell that just from the discriminant, or if you have a graph of the quadratic, obviously you can tell from that. Okay, so now we're going to look at some word problems. Let me copy and paste those in. The Texas Parks and Wildlife keeps track of a pool of fish in a certain area of Lake Sam Rayburn. They find that the fish population F can be modeled by the f of x function, where x is the number of weeks since the deadly algae bloom. The algae bloom, which occurred 6 weeks ago, is toxic to not only the fish, but also to humans. That means even touching the fish will poison you. As such, they have forbidden any fishing in the area of the bloom until the fish have reached a population that is back up to 145 fish per square mile. How long will it take until the LHS fishing team can get back to their honey hole on Sam Rayburn? So we're looking at our f of x function. I'm going to copy it down here. And we're told that they can go back to fishing as soon as that has reached a level or is equal to 145. So you could figure out when this equation is equal to 145, or we can take advantage of our quadratic formula by subtracting this 145 from both sides. And then we have a quadratic equation set equal to 0. And that makes things a little bit easier. 306 minus 145 is positive 161. So now that I have a quadratic function set equal to 0, I can identify my A, my B, and my C, and substitute those into the quadratic formula. So we have negative B plus or minus the square root of B squared minus 4 times A times C, all divided by 2 times A. So when I'm simplifying a quadratic equation with this many numbers that are not numbers that I can calculate in my head, I try to simplify this in 3 pieces. I'm going to take care of the double negative here. I'm going to simplify what's under the radical, and then I'm going to simplify the denominator. So the negative 31.84, the negatives would cancel, and then plus or minus, I'll go calculate what's under the square root and in the denominator. So I'm using this calculate 84, the pink calculator down at the bottom. It looks just like your TI 84. So under the radical, we had parentheses negative 31.84, close parentheses, squared minus 4 times my A value times my C value. So 79.3416 is under the radical. And then I also did on the calculator 2 times 1.451 is 2.902. And so then to calculate the 2 solutions that come from that, you need to do the plus and the minus. So 31.84 plus that square root. In my calculator, I got 14.04. Make sure you practice doing that calculation and getting that answer. If your calculator has been updated, you can push alpha y equals, and then that first option that says frac will give you fraction boxes, so you can do this calculation. All over 2.902, and you'll get that 14.04 that I wrote down. If your calculator does not have the latest operating system, you would want to open a parentheses and type in your numerator and close the parentheses after the square root, and then divide by that denominator to get the correct answer. So you either enclose the numerator in parentheses, or you do the alpha y equals to get the fraction boxes. Okay, and then the other answer with minus that gave me 7.90. So what's happening in this situation? We have a positive discriminant. So we know that that means our graph never touches the x-axis, or it doesn't have a solution. So it could look something like this. I'll graph it over here to the side. So this first number, the 7.9, would be when it reaches, let's say this is 7, when it reaches 145 fish population on the way down. That would be after the algae bloom, the fish are dying off. They go down and reach their lowest point and then start to rise back up. And it hits 145 again at that other time, 14.04. So to be safe, you would want to always round up. It's a long way from 14.04 to 15, but you would want to go up to that 15 weeks mark to know for sure that that is a safe time to fish in that area again. Okay, before we go into our next word problem, there's one other thing I need to go over. That's the Pythagorean theorem. We will use that on our next problem. So the Pythagorean theorem says that in a right triangle, with legs of length A and B, and a hypotenuse of length C, the Pythagorean theorem says that A squared plus B squared is equal to C squared. So that would look like this kind of triangle. A and B would be the two legs, and C would be the hypotenuse across from the right angle. So I'm going to do another example that's not a word problem before we do the word problem that goes with this. So we want to find the length of the diagonal of a TV if the height is 63% and the width of the width, sorry, wrote that wrong. The width is 52 inches. So from what that is telling us, we have a TV with a height equal to 0.63 times the width of 52, or 32.76. So if this was our TV, it has a width of 52, and we calculate that height of 32.76. And then we want to calculate this diagonal length. So the corner would obviously be a right angle. So these two values would be the lengths of the legs, and we're looking for the hypotenuse length. So we could set up our Pythagorean theorem. 52 squared plus 32.76 squared equals, if I label this as the diagonal, D squared. So if I put those two values in the calculator, I would get 3,777.2176 equals D squared. And then square rooting both sides gives a diagonal of 61.5 inches, which is the size of the TV that would be advertised. When they advertise the inch value of a TV, they're talking about the length of the diagonal. Okay, word problem number 2. Tyrone the tire man and Miguel the manly man have purchased cheap walkie-talkies to use in their shop and abroad. They have had a slow day and decide to start clearing their land of trees in dreams of having a bigger shop. Tyrone gets in his tractor and starts clearing the land at a pace of 2.5 miles an hour, heading north, while Miguel gets in his tractor and starts clearing to the east at 3 miles per hour. How long can they talk if the walkie-talkies can reach a maximum distance of 4 miles? And then we'll round to the nearest minute. So they've got some starting point. One of them is heading north and one of them is heading east. And it says Tyrone is heading north at a pace of 2.5. Miguel is heading east at a pace of 3. So again, we can use the Pythagorean theorem to find out the pace across there. We have a maximum distance of 4 miles. So we would want that to be 4. Okay. So if Tyrone is traveling 2.5 miles per hour. And Miguel is traveling 3 miles per hour. We're going to look at how we can convert miles per hour into miles per minute, because it's asking us to round to the nearest minute here. So if I know something is in miles per hour, if I multiply by hours in the numerator and minutes in the denominator, I want to make that a value of 1. And I know that 1 hour is equal to 60 minutes. So that fraction is equal to 1. So if I take each one of these and multiply by 1 hour over 60 minutes, I'm converting those paces into miles per minute, which is what we would want to use in our Pythagorean theorem. So we would do 2.5 over 60 x for the distance traveled by Tyrone, plus 3 over 60 x for the distance traveled by Miguel, because they're traveling the same amount of time. And we want that to be equal to their maximum walkie-talkie distance of 4 squared. So again, using the calculator, that gives me 0.041 and then 6 repeating x squared plus 0.05 x squared equals 4 squared is 16. So squaring those values and adding them together is 0.004236 x squared equals 16. Dividing by that decimal, I get x squared is equal to 3777.148. Square rooting both sides of this equation will give me that x is equal to 61.4577. So that means they would have approximately 61 minutes where they could travel apart from each other and their walkie-talkies still work. Okay, and again, I encourage you to practice typing these numbers into your calculator. Make sure that you are able to do these operations. Don't just write them down and then assume that you'll know how to do them for the test. Because you don't want to get stuck on the test not being able to function with your calculator. So make sure you're practicing those skills. Okay, and our last word problem here. Jose is building a sidewalk around his taco stand. The taco stand is 10 feet by 6 feet, and he wants the sidewalk to have a uniform width. If he only has 36 square feet of material and no money to buy more, how wide should the sidewalk be? So to try to put a visualization with this description, we have this taco stand that is 10 feet wide and 6 feet in depth. He is putting a sidewalk outside of this stand that he wants to cover the same distance all the way around. So we could say the sidewalk has a width of X. So what we really need to look at is just the width of this perimeter, but it has some depth to it that we have to consider. So when I look at that overall picture, I could say that this side of the stand plus the sidewalk, it would be 6 feet for the depth of the stand, and then the 2 pieces of sidewalk on either side. So it'd be 6 plus 2x. And then similarly on the width, the taco stand itself is 10 feet plus 2 sides of the sidewalk. So X represents the width of the sidewalk. And then if I calculate the area inside of the sidewalk, 6 plus 2x times 10 plus 2x, that's giving me all of this area, including the taco stand. But the taco stand would not be sidewalk. So when we consider the 36 square feet of material, that is just for the sidewalk. So I need to take away or subtract out the area of the taco stand, and that needs to be equal to 36. So I need to solve this as a quadratic, and that means that I need to simplify as much as I can, have it in the form of a standard quadratic and set equal to 0. So I need to begin by multiplying these two binomials together, which we did in our very first lesson. So double distributing, I get 60 plus 12x plus 20x plus 4x squared. And then minus 10 times 6 is 60. It's 36. Combining like terms on the left side, this 60 and minus 60 actually cancel out. So I would have 4x squared plus 32x equals 36. And then I want it to be set equal to 0. So I'm going to subtract the 36 from both sides. And then I have a couple of options. I could go straight to the quadratic formula, or I could try to solve this by factoring. I'm going to do this one by factoring just so that you have an example of both, but the quadratic formula will always work. For this one to factor, since I have a number in front of x squared, I want to see if I have a greatest common factor that these can all three divide by. And I notice they'll all divide by 4. So I'm going to factor out that 4, which will leave me with x squared plus 8x minus 9 equals 0. And then with what's in the parentheses, I can find factors of -9 that add to give me a positive 8. That would be x plus 9 and x minus 1. 9 times -1 is -9, and 9 plus -1 would be positive 8. And then using the 0 factor property, I have 3 things that multiply to give me 0. So that property says that 1 or more of them has to be equal to 0. Well, I know it doesn't make sense for 4 to be equal to 0, so that's not useful to me. And then the x plus 9 equals 0. Subtracting 9 from both sides would be x equals -9. It doesn't make sense for a sidewalk to be -9 feet or negative anything, so I'm not going to use that one. And then adding 1 to both sides, I get x equals 1, and that's the only sensible solution. So the sidewalk should be 1 foot wide. It is possible to get more than one sensible solution, in which case you could just give 2 options. Usually in a case like this, you're only going to have one that makes sense.